Hello, everyone. Thanks for joining us. So we're going to have today's session on Apstra. So I'm Mehdi, and my partner in crime, Adam. So we're going to have a session on Apstra today. So I don't know how much of you here knows Apstra or not. It's going to be a on purpose, like a general presentation initially to start with, and then we can go into a little bit more details. So I'm one of the product managers. I'm based in France, as you can hear from my accent, which, trust me, is not as worse as a British accent. But let's dive into it.
Right, well, I'll leave you to get on.
So, OK. Right, so this will be structured in kind of three parts. So the first part will just talk about like why HPE Juniper in the data center networks domain, right? And then we'll go into explaining the actual fundamentals of Apstra, like how it all started, what's the concept behind Apstra, what's the concept behind the so-called intent-based networking, and really like the core principles, the core architecture, and the fundamental philosophy of the product. And then Adam will then take over with the AIOps part, which builds on top of the core elements that we're going to talk about. So first of all, like, what are we talking about? We're talking about data center networking and data center networking operations. So why HPE in this area, right? So, well, it all started with a fundamental different way to operate networks. So we will talk about this throughout the presentation. But when Apstra was initially created, it was like an independent startup, which was then acquired by Juniper a few years ago. It all started with this fundamental idea that we wanted to bring like really like cloud-like operations to the enterprise customers, right? So it was really inspired by a lot of like hyperscale way of deploying and operating networks. So one of the kind of secret sauce that really we relied on early on, it was one of the very first, I would say, engineering design decisions that we made that still pays dividend today because it gives us like a significant competitive edge and compared to the competitors. It is the notion of the contextual graph as we talk about it. So what that is, that's the way we have to capture the user intent, right? So Apstra has been the pioneer of this notion of intent-based networking. We needed a way, an efficient way to capture the user intent and model it in a way that we can reason about, right? So reasoning about the user intent is really, what helps you, of course, render configurations and do it efficiently, and then, render, a number of expectations from the telemetry side that your network has to meet to declare your intent as being valid, right? And then, of course, there is the missed part, and Adam will talk about this in more details, right? So now this foundation allows us to really deliver on a number of outcomes that we wanted to have. So those outcomes are really here: insight, speed, and reliability. So I'm going to start with the first two, which are really probably the most two important ones that are hard to reconcile, like speed and reliability. Like when you operate a network, you want to do things as fast as possible, but you want to also do that in as reliable manner as possible, right? And often we had this, this traditional dilemma to you either take the time to do something and you do it reliably, or you can do it fast, but you can risk breaking stuff. And the idea here is to really reconcile the two and brings in a box the ability to deliver services as fast as possible in an extreme reliability. And of course, insight is a crucial part here because data center networks are distributed systems. They are complex distributed systems. It's a distributed state, right, across the leaves and spines and servers and so on. So there is a lot of metrics to gather and collect and contextualize at the system level for you to claim whether your network is delivering on the outcomes you want and the states that you want. So Insight is really about gathering telemetry and making use of this telemetry in very efficient analytics pipelines that contextualize all of this data. So the outcome of that is, or the result of that is of course, a leadership position in the Magic Quadrant. So let's go straight into that. So this is the latest Magic Quadrant. It was March or April 2025 this year. We moved, Juniper moved into both dimension, like horizontal and vertical, one of the very few vendors who moved up and like onwards and upwards based on the latest Magic Quadrant, which was like 5 years ago, or 5 years before that. There is also another deliverable, which is probably as valuable as the Magic Quadrant, which is the critical capabilities. So critical capabilities rates the capabilities of a vendor in different domains. So when you look at enterprise data center build-out, we are number 1. And number 2 in GPU like AI networking, like AI networks, right? So it's really a testament to all the efforts that have been made in this area. Right. So now, like, why we need to talk about this notion of intent and context and what does it really mean, right? So a little bit of background, right? So a lot of times, innovations, comes from people who build companies based on a unsatisfied status quo. So what you see here are really like the founders on the Apstra side as well as on the Mist side. So just like these are people who basically have been running either like founding companies, like for example David Cheriton on the left-hand side, who was one of the founder of Apstra, first investor in Google, founder of Arista, founder of different companies, and so on. Sasha Ratkovich, who was one of the distinguished engineer before joining Apstra, and basically also one of the OpenStack lead chair. So these people are basically those who were were not able to solve problems with the current set of technologies in their current company. So they basically left to create Apstra on one side and Mist on the other side. And really the architecture of the solution that was built was really the right one from day one, which allows us to scale and add the right features that we need. So to put some perspective, when you think about data center networks, when you create an enterprise data center network, typically you talk about EVPN networks. There is a lot of steps that you have to go through, right? So what you see here is like you start with your physical devices. You have to look for the cabling. You may have breakout or not. Then you have various steps of configuration. So we talk about underlay configuration. So when you deploy EVPN fabrics, you use BGP. So you need to have ASNs, loopbacks. You need to create your underlay BGP sessions. And then if you run EVPN, you need overlay BGP sessions. So that's another type of signaling that runs on top of your underlay with its own configuration attributes, and all of that must be synced in a way that works, right? So the principle here is that the evolution of these networks reached a point where it's very difficult for a human to cope with this complexity in your head. It's just impossible, because there are too many parameters. Like, it's okay on a 4-leaf network. It's really not okay on a larger network. So this cognitive load is really something that we needed to simplify. So the solution for that came from this idea to represent the user intent in a way that we can reason about. And that representation is a graph. So what you see here on the left side is the way you visualize the data center. So this is a small fabric with 2 spines, 4 leaves, and 8 servers, right? And you think that this is a small network, right? The way we visualize this is like what you see here on the right-hand side, which is a graph that combines both physical elements and logical elements. So it has the leaf, the spines, the servers, the interfaces, physical interfaces, the loopbacks. It has nodes for BGP sessions, for ASNs, for various resources, nodes for various nodes for EVPN configuration and everything. So, and the graph is a way to represent how things are connected together, exactly like what your mental model will basically do that. And actually, the idea is on an average network, you will end up with graphs that are much larger than that. So this is a starting point for us to represent the user intent, which then provides a number of outputs. Those outputs are configuration on one side and telemetry collection on the other side, with telemetry validation. So let's look at the type of checks that this allows you to do. So the first thing when you want to automate your network, right, you need to make sure that you have a focus on day 2 part as well, not just the build out. Because let's be clear, starting from 0 to 1,000 racks is not the most complex things to automate. It is much, because there is nothing to break. The blast radius is 0. However, the very small change in a network that has 4 racks and 50 VLANs is way more dangerous to automate than going from 0 to 1,000 racks. Because there is a blast radius. You can break something. Okay? So you must ensure that your automation system protects you from yourself, meaning you don't automate errors. So how you do that? You build a system that has a lot of input validation. Because the system has a semantic understanding of what the network is. Like semantically, it understands it. You're not providing it configurates, right? The system is able to reason about your request for a change. I'm requesting to add a rack and to stretch a VLAN from these racks to these other racks, whatever. This change goes against like a list of input validation that are gating basically any incremental configuration in the network. Nothing is pushed to the network if it doesn't pass those checks. And those checks are very extensive. Just with that, you protect basically the customer from, or the user from himself. You can think of it as precondition check, right? So what you see here on the right-hand side is just an example of someone who has deployed various VLANs in various VRFs and decide to take like one virtual network and move it from one VRF to another. Okay, and at that moment in time, you get like an error message saying, hey, you can't do that because there is like another instance that run in that VRF with the same IP address. So that's an IP conflict. It's a simple example, yet a lot of products don't offer this kind of input validation. And it's absolutely crucial for this speed and reliability aspect. So what you see here on the right-hand side is just a list and extract of the many input checks that the system has embedded from day one. And I think we exceeded the 400 checks on all sorts of things that go beyond just like a syntactic validation. It's a full semantic system-wide validation, right? So that's the first part, which is really input validations. And then once, OK, before we continue, so this thing, of course, is real, right? You can see here just examples of some of the public codes from different customers. So First Bank, one of the very first customers when we have been acquired by Juniper, is basically saying, I designed the network before we had our switches, and because it was right in the COVID time and so on, and fully operational the moment we plug the switches when they arrive, right? So this is this idea that you don't need, with Apstra, you don't need a digital twin, right? Because basically all this input validation, kind of invalidates really the need for a digital twin, and in fact, it's more efficient than a digital twin in many situations. Server Australia, basically another code, where they shorten the service provisioning from 8 hours to 30 minutes. And I like the 2K Games is like a video game company. If you're like into basketball, they have very good NBA basketball video game, where they basically shift, they're saying clearly, we shift our configuration from configuration devices to basically building automated connectivity services. So this is an example of really the change in the philosophy, right? So once you have done that and you have passed all this input check validation and you can basically commit your changes, right? You have to then validate the state of your network, because checking a golden configuration is one thing, but that's not enough, right? Doesn't tell you if the network is actually delivering on what you need. So we collect a lot of telemetry, but to analyze this telemetry, you need to do that in context of your intent. So what you see here is an example of a network that has 32 spines, 200 leaves. It is a large network, but it's not a hyperscale network, right? And this network results just in the underlay, in 1.5 million entries in the routing tables across all the leaves. So this is something that, now we move into the post-condition checks validation. This is how the artifact of the graph, the result of computing this graph, gives us very detailed expectations that are generated, therefore creating a telemetry collection, a very specific telemetry collection compared to a list of expectations. So you cannot imagine a human being able to cope with this of 1.5 million routing entries. Like if you lose one route, are you going to see it as a human? You cannot. And if I add remove racks, this is updated real time. So the idea is that the result of this approach, this whole intent-based networking approach, the result of that is that you automate your validation step in the presence of a change. Whatever change you do will update the expectations. And if there is anything, any state or entry in the network that does not match these expectations, you get a notification, which is very different from saying, oh, I checked the configuration. It's fine. So expected versus actual state comparison, right? Now let's move into a little bit more advanced case. I have validated my underlay, but I am doing EVPN, right? So when I do EVPN, what is happening is that, so let's go into a little bit more details here. When you do EVPN, it's a control plane that allows you to distribute layer 2 between servers, right? You extend the layer 2 over a routed network. That's what EVPN is. So fundamentally, you take a service which is a layer 2 service, and you have a routed control plane that distributes this. Okay, so a switch will typically learn MAC addresses locally, and then you will have what's called EVPN type 2 routes that are propagating this MAC learning to the remote leaves that are participating in the same VNI. And then the remote leaves will then in turn program this locally in their local MAC table to emulate a big switch that in fact is a fabric. That's how EVPN works. So what this does is basically combining dynamic states, meaning the MAC entries into every leaf, the intent, which is what's my virtual network, what's my VXLAN intent, like what's the footprint of every one of my VXLANs, and making sure that whenever there is a switch that learns a MAC address locally, it looks for all the remote leaves participating in the same VNIs, and it expects the MAC entries to be programmed locally as a result of the protocol convergence. If not, it's flagging an anomaly. You cannot do this kind of validation if your system does not have a complete understanding of what your intent is. Understand what a layer 2 VXLAN is, what a layer 3 VXLAN is, and be able to derive states on leaves that are the result of multiple factors. So that's an example here showing that, for example, some VXLAN services have had missing MACs, meaning the switch did not program the MAC as it should, right? So yeah, again, just an example here. Yeah, so that's the other screen capture. You can see here the number of virtual networks containing missing MACs. So it's really like more an overlay type of validation. So really a big focus on day 2. Some codes there. So okay, AIOps, very big service provider in Europe that we have across multiple countries. And Vodafone, another customer who also had a lot of day 2 troubleshooting scenario, and that is actually relying on these EVPN validations. Even in multiple vendor scenario, these 2 customers are using it in both Juniper and non-Juniper deployments. Okay, so from here, what I want you to go away with is this. When you think of building a DC network and operating it, it's probably true not just for data center, but you spend what? I don't know, 3% of your time in day 0, right? You spend like 2% of your time These are just very, very high level numbers, but you spend 5% of your time doing your design and then your build. And then when you look at your entire life cycle, let's say 3 years or 5 years investment, right? When you build a new infrastructure, the vast, vast, vast majority is day 2. You scale by adding servers, adding racks, adding, moving, deleting services day in, day out. It is what causes the highest stress. The entire product has been designed to completely de-risk this. If we do design and day 1, it is to serve a better day 2. That's the reality. So example, you add VXLANs, you add racks, you provision border gateways, you change routing policies, filtering policies. You do NOS upgrade. You remove stuff. This is also typically something that you have to do in an as clean way as possible. You remove VXLAN services, how you make sure that you don't forget any existing configuration. You migrate services. You replace devices. You have an RMA. So how do you make sure that when you remove a switch and you replace it with a new one, after RMA, you get the same state and you get the right configuration being pushed to it and so on. So a big, big focus on this. So the idea is speed without compromise. You break free with this forced choice of I do stuff fast or reliably. You do them fast and reliably at the same time. Still? OK, 5 minutes. OK. So that's the foundation. And then we expose a number of capabilities as a platform capability as well for you to customize and build on top of the existing built-in capabilities to customize it to your needs. So the idea is that, OK, what if I need to monitor additional metrics, right, that are not monitored or captured by default, right, by Apstra? How can I expand beyond what is monitored? So we have this platform capability that allows you, within the product, to fully customize your monitoring and analytics. So you can define customizable data ingestion. You can, starting with the simple show command, you can specify the show commands and the specific fields that you are interested in. So customizable data extraction, so data ingestion from the source producing these data, which are the switches, and they produce a lot of data. And then you can wire that into customizable data processing pipelines. That is it's a no-code solution. It's a drag and drop. You can define the type of processing you want to do on this data. And then the result of it is customizable visualization with various widgets, like composable widgets and dashboards that you can customize yourself. So what you see here at the bottom is the interface to specify data collection, additional data collection. So it starts with a show command and then specific fields to extract from that. And then you create data processing pipelines, right? So you can then start, define your logic to extract an insight from this data. You may want to do comparisons or some correlation between different data, right? It's a way for you to codify your troubleshooting scenario. As a network engineer, you are used to troubleshoot and typing CLI commands, and you are used to do this exercise to compare certain elements together. So all of that can be automated. You can drag and drop and create your kind of troubleshooting workflow in the form of a pipeline. And then you can choose your visualization types at the end. In this case, it's a threshold-based on a time series database. And there you go. This will then be available just like any built-in capability. So that's an example we did for a customer who wanted to have 8-to-end latency, leaf-to-leaf latency on the underlay, the overlay. We helped him create this additional data ingestion, a small pipeline, and he gets this time series database, which is displayed exactly like if it was a built-in dashboard. So all of that is really to give you the toolkit, so to speak, to go into analytics capabilities, right? And every time you do this, you benefit from the graph context. So every time you need something from the context, from the graph, you can use it and yeah, leverage it on top. That's it for my part. So Adam will take us to the next step.
Thank you very much.
Yeah.
Am I on? Yeah, okay, good. Yeah, hi everyone. So Mehdi has spoken about the context and how we take you through this journey and this path to create an understanding of the data center network you build, meaning that all the data that we receive is very refined. So we've now been moving into AIOps as well. It's taking a lot of the data that we already had and making it useful in a way to you that is kind of allowing your engineers to free up and for you to observe problems before they even happen. Who has got a data center out of interest? Has everyone got a data center? Okay, all right, okay, most people, that's good. So one of the big challenges that we typically see with customers is they have this visibility disconnect between the infrastructure and actually what's running over the infrastructure. So for example, if you lose a switch or something goes down, what's actually affected? Who's affected? What services are affected? Is it the service that you're providing to a customer? Are they able to use that service? It's typically not known, or it's typically a combination of different teams coming together to work that out. So this gap that has been around, and so a lot of customers we speak to have that. We've been working for the last 18 months to take all of that infrastructure data, all of the traffic flow data that we're getting as well in Apstra, and then putting it into one platform called Data Center Assurance and using some different ML, well, firstly doing some correlation, showing you that data view together, and then also doing correlation using ML to actually do things like predictions, and also our Marvis AI bot. So if you've used the Mist campus fabric or you've used Mist in any way, the term Marvis will probably be similar. But the point being is that we want to try and remove those blind spots and bridge that gap for you. And then I think most vendors use a version of this, so it may be similar, but there's these 5 stages, and the whole point is that we want to get to this autonomous network where it's actually going to go ahead and fix issues for you. It's still, for me, quite a scary thought that something is going to go ahead and make changes on the network, but that is the direction we're trending, and trust is, I think, slowly starting to build. But it's kind of like self-driving cars, which is the common example. They didn't just appear overnight. We collected data for a long time, and then we kind of progressed through that. And I was actually in Austin 2 weeks ago, and I took a Waymo taxi, which took me from one side of Austin to the other with no driver, which was incredibly freaky, and went down a one-way road the wrong way, but it was, for the most part, it was there. And this is where we've been focused for a long time. So Mehdi spoke about how we collect data, and that is really the core of it. Ironically, it's the first step, but without useful data, you could have the most complex or most sophisticated ML algorithm in the world. It doesn't matter. It's still going to give you garbage at the end. So we've been very focused on that piece. And it's actually probably a byproduct even way before this was even kind of considered a use case. But what we've been focused on recently is the recommendations and the assistant piece. So we have our predictive insights, and that's what I'm going to talk about next, and we also have our AI assistant. The predictive insights is all about changing that mindset from, I'm waking up at 2 o'clock in the morning trying to firefight something, to telling you, 4 weeks in advance that something is going to happen. We have a couple of use cases where we started. So system health is quite well understood, and it's kind of a common one that you see. So that's where we started, but we're also looking at capacity planning. Some of our customers, they don't actually know about they're hitting their capacity limits until it's kind of too late. So this is all about trending and understanding what port capacity you have. And especially if you've got seasonal networks where some seasons are very different to others, actually understanding the trend and how it's raised over years and years can be very helpful. And the final one is transceivers. Transceivers are those tiny little pluggable things that you put in your switches and in your servers. And they fail very slowly. They don't just fail. They typically don't just turn off. They fail over weeks. And the failure is you don't typically see because the network is very good at recovering from that and hiding it. And unless you're really looking for it, it's kind of really difficult to tell. So what we do, if you turn on the predictive analytics, for about 30 days, we monitor the network. We don't do anything. We're just trying to get an initial baseline. And once we have that baseline, that's when we can start looking to the future and understanding, A, this is what your network looks like. But there are some things then when it starts to step out of line, we can start to alert you on. So everyone talks about AI and AIOps. So we use two different machine learning algorithms predominantly in the product. So we use gradient boosted decision trees, because it's very good at classifying data down, asking questions and classifying it to see if data is normal or anomalous. And then we're also using long-term, short-term neural networks. And the point of that is that a neural network is very good at taking data, doing some processing and giving you an output, but it has no concept. If you add some more data in, it doesn't remember anything. So the long-term, short-term bit is actually about remembering the previous state, which is very good for predicting things like seeing a CPU rise up over time. This is what data center assurance looks like. And if I go in, I can actually look at some of my optical health. Here I can see that I've actually got two interfaces, and it says severity low. And the reason is because this platform is actually focused on user experience rather than necessarily the network. Because ultimately the network is there to provide a service for all those applications that are running over it and the users that interact with it. So it's okay having the plumbing on, but if it's not working very well for the user, then it's kind of a bit of a challenge. But this is another view that we show, and you'll see that if you look to the left, this way, and then all the way up to the top, that's showing you the confidence and also how quickly before an issue is going to occur. So something like a transceiver, we may know weeks in advance that transceiver is going to be affected. And we can tell you the confidence and how critical it's going to be in the impact. And by that is how many users are going to be affected, which applications won't be able to talk to each other, are they key ones that are typically being used on your network? And then if we drill in a bit more, you can start to look at this particular optic issue, for example. And this is laser bias. But in this chart over here, on the left-hand side of the horizontal line, is the current data that we have. And then everything to the other side is actually the prediction. So you can see it started to step out already. And now you can actually start to trend up and up and up until you see that failure. And that's what we alert you on. So we can predict on that. So it's all about a mindset shift. And we have one customer who was able to turn on the optical analytics in Apstra. And they'd had some issues where they'd had a couple of networks where they'd replaced optics, they replaced cabling, they'd done some troubleshooting, but they hadn't really done much else. But they turned this on in Apstra, and they were able to see they had about 8 optics in the network that were still actually failing at the current time, but they had no idea about. So that could have been, well, probably would have been 8 separate outages. And by seeing that, they were able to see it was the same vendor and the same batch number. So with their optics vendor, they RMA'd that full set. So they were able to actually be proactive and actually able to, well, one, stop the failure, but correct it on their own time, rather than it being an emergency change or the middle of an outage. So that's predictive, and the other piece is more the assisted element that we've been looking at. Has anyone used Mist before in the campus or Wi-Fi? Yeah? Okay. So the Marvis agent has been around for a while in that space. Someone said it to me that that's kind of like the growing up, and then we've kind of have this toddler that we're still training and bringing. But the whole point of this Marvis agent is got 2 outcomes that we're trying to help our customers with is, one, anomaly resolution. So not just telling you that you've got an issue, but also how do you solve it. We haven't gone as far yet to actually resolve it for you. I think so the trust element is probably not there. And the final one is knowledge retrieval. How can we, if you ask questions about your network and about what's going on, what data is there, how can we actually give you sophisticated answers that actually are possibly meaningful to you? And we started building an agentic framework in the background. Again, another fantastic word that's been thrown around a lot is agentic AI. But when we say agentic AI, if you look at a standard large language model like Claude or ChatGPT, it's a really good conversation partner and an amazing tool, but it has no eyes and ears in your network. It doesn't actually know what's going on. It can tell you about data it's trained on at a certain point, but that's it. The agentic framework is still the same as having this LLM, but the large language model is actually now in the middle, and it's instead of just trying to give you a response, it's trying to work out what you're trying to achieve and how to achieve it for you. And the way it does this is using all different tools. So in our case, we can query the flow data that we get, the infrastructure data from Apstra. We can look at internal support cases as well as public documentation, knowledge articles. It can also go in and talk to other applications. So tomorrow, I'm not sure what time, but our VP of Data Center, Praveen, is actually going to demo the chatbot that we've got as well, and there's some ServiceNow piece in there as well. But the whole point is that that's going to go ahead and start thinking about what it is that you're trying to achieve and predict the questions that you're going to ask and answer it for you to give you this kind of complete root cause analysis. And then this is a couple of screenshots. So the UI has actually changed since we submitted this presentation. But this is if a user is asking that someone has complained they've got an issue with their network on an application, and is the network actually causing it? Well, you kind of notice that instead of just going back and doing things, it can actually run queries, and it's querying those data sets and trying to make sense of those data sets and maybe look at knowledge articles to understand how it could go through different troubleshooting steps that our JTAC have done in the past. And in this case, it kind of gives you an answer to say, well, yeah, there's been some network disruption, there's been some BGP sessions that have gone up and down, there's been some packet loss, all around where this service is actually living in your network. So it's highly likely, and then you kind of continue through the process of talking it to get to that root cause. And if you have used Mist before, there's something called Marvis Minis, which a lot of the data that we collect at the moment is very passive in terms of, we're going in and asking questions of what's actually happening in terms of collecting flow data, for example. You're not living in the network. But these are actually agents that are going to run, and they can simulate applications. And it allows us to do things like understand what the end-to-end experience is for that user, whether the user being a physical person using it or two applications talking to each other. Something that's typically hidden. So this platform is all around making it more centered towards user experience and also helping you diagnose issues. So in terms of kind of the outcomes that we're trying to drive, it's all about reducing, well, I guess, mean time to innocence or mean time to resolution, giving you the information and it being to the point, rather than having to, A, find out there's an issue and then work out what the root cause is. And then we're also looking at, if you read a couple of studies, a lot of network engineers are typically leaving the field, through retirement. But the engineers that are coming in typically are not specialized just necessarily on networking. They've got kind of multi-domain knowledge. So it kind of means that you have this, we are going to end up with this gap. So having a platform like this that is like an agent or a co-pilot that can sit beside you and help users, A, learn and understand what the network is doing and how to do things. So trying to democratize that knowledge is kind of key thing that we're focusing on. And then proactive operations, so even actually shifting the mindset completely. Moving from that reactive firefighting, 2 a.m., midday, getting calls from users, to actually being able to say, well, we know something is going to happen, so on our terms, we'll actually set a change window and actually make changes, rather than it being a frantic mess, which is kind of the dreaded thing. And I guess this point 4 really overarches everything, which is it's all about consistency. These kind of things, they don't get bored. They're not bored of monitoring. They run 24/7. This would be my worst nightmare, doing this as a network engineer. In the past, I would not have wanted to do this. So having something that would do this for me and look at the statistics and the correlation that I would never have done, I think is incredibly powerful. So where we're going now, moving on, we are looking at adding in MCPs, so about integrating more and more solutions, so again, integrating with a wider ecosystem. So this platform isn't just a closed loop. You can actually use things like ServiceNow, for example. You could even open tickets and add your troubleshooting information. Allowing these ML workflows to actually talk with each other, which is something if you've started looking at some of the coding projects that people are doing with Claude Code and things, you can actually have agents talk to each other and ask questions, and they run their independent workflows. And then very far in the future, how do we actually look to help resolve issues automatically instead of relying on someone to actually go in and do it? I think we're still quite away from that. I said the trust isn't quite there at the moment. But that's where we're heading. So the Apstra platform and speed, reliability, and insights are the 3 core pillars that we're focusing on. And I think we're at booth 606. I think it's 606. So if you do want to actually see Apstra and kind of play around with it and show up, we can give you a demo and show you how it works and look through the UI. Might be interesting to some of you. So yeah, other than that, there's some community information. So if you're part of the Aheads or the Elevate Juniper community, you can go there. And then, yeah, thank you. So that's it. Okay.